Since we view inventory as waste, then transportation can be viewed as a way of accumulating inventory on the move, which is, of course, something we want to eliminate also. If we can tie all production processes with an invisible conveyor, producing one piece at a time and transporting one piece at a time, we would have the ideal flow production system. Here, transportation is represented by valves connecting separate pools of inventory in the manufacturing process. If pressure builds up for too long before the valve is opened, the discharge of inventory is similar to a discharge of water from a dam. From this analogy, it should be obvious that transferring materials in large batch sizes creates a glut of material flowing in a disorderly fashion. Because of this, new roles for the transportation function may be developed in order to pursue the following objectives: more frequent deliveries, more frequent feedback of information between the processes, for example, quality problems, work priorities, and the like, no storage in between the processes, and reduced transportation costs. Even though some of these objectives may seem conflicting, we can still address them by using our creative thinking. For example, transferring Kanban cards may convey accurate production information to the upstream process. Mix loading of trucks and multi-plant scheduling may allow frequent small lot deliveries. Returnable containers may reduce material handling costs. Furthermore, we may be able to develop a one-touch handling method and deliver the material to the point of use. Let's compare some conventional and innovative approaches to transportation with this illustration. First, the conventional approach. This represents large lot, infrequent transportation. The results are slow feedback of information, an accumulation of inventory, and additional problems impacting quality and increased expediting work. Next, this shows a mixed loading arrangement. Parts are delivered more frequently, inventory levels are lower, and the entire situation is much more streamlined.
The transportation loop is similar to a bread truck route in that the truck begins empty from our plant here and runs a fixed loop in a fixed time, stopping at numerous vendors and returning to the plant full. The loops obviously vary in the length of time that the truck is on the loop, the frequency of pickups, and also the number of trucks that are on the route at any one time. The result was a savings of 1/3 to 1/4 over previous transportation costs.
In incorporating the Kanban theory here at Apple, we have eliminated a lot of our inventory. We have downsized our inventory considerably. Also, we have now utilized a truck instead of a rack, which is warehousing material in-house. We now warehouse it in a trailer on the lot, and it is utilized as we need. We generally have 2 trailers of full material of each product sitting on the lot at any one time. One will be backed up to a door. The other is sitting there in case this one, when it gets emptied. Upon emptying this material of the one at the door, we then return it back to the vendor, pull up the other trailer, and the vendor in turn fills it up and sends it back, which means we always have a continuous loop of 2 trailers on the lot at all times. This has really helped in a positive manner. It has eliminated a lot of our inventory in the racks in the warehouse. It's given us more space, more flexibility, and it has really helped in a lot of the teamwork. It's a lot easier to deal with it out of a trailer than it is to pull it out of the racks.
What we're doing here in Apple Fremont is trying to utilize our packaging as much as possible so that we can bring the cost of the unit down per part. And we brought the we've recently brought the plant up on a reusable packaging program, and what I'd like to do is show you how we've utilized the packaging in such a manner that we have no waste and we recycle the packaging through each of our vendors. What we have here is a Mac 2 bottom, and what you see here is a piece of sheet metal in a piece of plastic. The packaging starts at the sheet metal supplier, and the sheet metal supplier stamps out this piece of sheet metal here. They will put this sheet metal in this box with partitions. You'll see that 4 tops are in this box. Sheet metal supplier puts 4 of the sheet metal parts in the box, ships it to our plastic supplier, who molds this injection molded plastic. They heat stake the sheet metal into the plastic, do prep work such as pad printing, logo, and feet, put it back in the same box with the same partitions, ship it to Apple. Comes here to Apple Fremont, we remove the parts on the line, send the packaging back to D-Trash, the people in D-Trash knock it down, send it back to the sheet metal supplier here. Thus, the packaging hits 3 different suppliers. What you see here is a design that makes it easy utilization for each supplier that it hits. We have an HSC style carton with no top flaps. Thus, the person that's working with this carton has no top flaps to get in the way of the utilization. You'll also notice it has handholds for easy access to lift and carry. What we do, this is a 1/4 pallet size. We bring 4 boxes in per layer, and there's a layer lid that goes over each layer. One person removes that layer, and we have 4 totes exposed. This packaging actually goes right to the line, and there's no D-Trash whatsoever. The parts are exposed, and nobody double handles the parts.
At Toyota Auto Body of California, parts are delivered to the line when the operator informs the trucker by electric signal. This signal turns an on board light on that informs the trucker what parts need to be delivered and where.
So this is basically an extension of flow production, a way to ensure that there will be very little inventory accumulated in the pipeline.
Yes, the key here, just like anywhere else, is to look at the overall picture rather than simply focusing on one's own efficiency.
Multiple delivery is an example, isn't it?
Yes, it may cost more to do multiple deliveries if we look only at the transportation cost. But if we look at the total cost, including reduction of inventory, space, material handling, and so on, it may make a lot of sense.
But to make this happen, we need to work together closely, right?
Yes, a good transportation network requires close communication too. So the closer the location, the better the linkage. Just as we talked about small lot and mixed lot production reducing the lead time, small lot and mixed lot transportation are also necessary to streamline the factory operations.